Databases. Here we'll go over the database choices. First, I'll explain the major types of databases, the various NoSQL types and relational databases. I will give examples of what would be a good use case for a database and what would be a bad use case for the database, as well as warning signs that you're misusing the database. By the end of this video, you should have a basic understanding of the various types of NoSQL databases and their key use cases, as well as understand what data models fit the best and understand the warning signs for misuse. Types. In the modern tech era, there's almost an unseemingly never-ending list of database systems to choose from. The list for just the types of database systems can seem daunting. Document-based, graph-based, key-value stores, and SQL database, just to name a few, are some of the kinds of database systems that are in use around the world. Each has its benefits and drawbacks. SQL. We'll start with one of the most popular types of databases. SQL stands for Structured Query Language. It's a language that has been created for querying databases. People write out queries to read data from the database. SQL is a standard. However, there are many different SQL databases, each of which has their own twist to the language. SQL databases are also known as regional database management systems. They are designed for relational data. If you have multiple bits of information that are related to each other, an SQL database is a good solution. There are different kinds of database relations. One-to-one, this is where you have one bit of data that relates only to another bit of data. For example, if you have an employee and their social profile, each employee has their own social profile, and a social profile record belongs to only one employee. The next kind of relation is one-to-many. This is where you have one bit of data that relates to other bits of data. For example, you have an employee, then you have a building entry records. An employee would have multiple building entry records, and a building entry record only applies to one employee. This type of relationship can also be described as many-to-one. Many building entry records relate to one employee. The last kind of relation is many-to-many. This is where you have a bit of data that relates to many other bits of data that also relate to many other bits of data. For example, you have an employee and projects. Multiple employees can work on a project. An employee can have multiple projects. In SQL databases, you store data that is the same in a table. Each field of data is... So you can have a table employee with columns ID, name, age, department, and role. In SQL databases, the way you deal with relationships within the SQL query is called a join. There are inner joins and left joins. Inner joins are mandatory relationships. The relationship has to be filled or nothing is returned. And a left join is an optional relationship where it returns an empty value when the relationship doesn't exist. One of the warning signs for a poor database performance is joins. If your application has lots of queries where there are lots of joins, then you can see performance issues when the data grows. One of the ways to combat this is to remove one-to-one relationships. When you need your database to scale, it's better to have all these in the one table. There is no performance hits for having larger tables. To improve the performance of your database, you should look at adding indexes. Indexes are optimized data that allows the database to search quickly through a certain column or certain set of fields, quickly find a match, and to ensure the select query only selects the data you want. There are many other types of performance best practices, but these are the two easiest to spot and to implement and work for all SQL databases. NoSQL. NoSQL often seems very mysterious. What is NoSQL? It seems the more you ask, the more answers you get. And as the name says, it's a database that doesn't use SQL. The way to query the database is often different per database. Document-based. A document-based database is a database that is designed to have all the information in one record. So if you have one-to-one relations, or if you have one-to-many relations, these should all be in the same record. Because all the information is in the same document, these databases can be very performant because they don't need to join multiple bits of data together. Document-based databases don't have tables or columns like SQL databases have. Instead, they have a document that can have various attributes and can be extremely flexible. These databases are good for data that doesn't have any other data relations or doesn't have many. For example, a catalogue of products would be good. Each product can have different number of attributes, or content management like a blog. Each blog can have different number of comments. Each comment only relates to one blog post. A warning sign you've got the wrong kind of data for your database is if you have joins manually by querying the database and then querying the database again to fetch other data before that data is actually usable. Graph-based. A graph-based database system is a database system where the relationship between the data is as important as the data itself. Within a graph database, the data is all stored together. Graph-based databases store their data as nodes which have properties. These properties can link to other nodes. The node will define its links to other data as part of the design. Key value stores. Key value stores are systems that allow you to store data based on a key and fetch it based on a key. They often contain a single value per key. There is no relationship between values stored and other values. These are very good to use as cache storage or sessions. Examples. Now we'll quickly go over some of the top databases. MongoDB. MongoDB is arguably the most popular document-based database system on the market. It's originally released in 2019, so it can now be considered battle-tested. MongoDB uses a modified version of JSON, which they call BSON. This is used for querying the data as well as storing the data. MongoDB has been developed to allow for a very fast rate of writing and has built-in support for replication by default. MongoDB does not support transactions. Transactions are when you group a series of queries together as a single transaction. If one query fails, then all the other queries are cancelled. This allows for making sure that your database is in the same state if you have actions that require modifying multiple different bits of data. MongoDB was designed to be a distributed database, which means it handles storing database across multiple servers. MySQL. MySQL is arguably the most popular relational database management system on the market today. It's originally released in 1995 and has been sold multiple times, once to Sun, then to Oracle, who still owns it today. It is arguably the most battle-tested database system on the market today. MySQL does support transactions. It allows you to have confidence in the state of the database, as always saying, and if you have multiple queries that rely on each other. MySQL is supported by almost every Object Relations Manager (ORM) on the market. An ORM allows developers to map database data to code objects with extreme ease and to query the database without writing SQL. ORMs can increase the speed of development, however they can result in performance issues with complex databases. MySQL was not originally designed to be a distributed. Performance replicas are often used. This is where you have a main server that is the source of truth and used as a write server, and then the replicas that are used to read from. There have been advances made to make clustering available within MySQL, however this is not often done and is considered advanced by many. Redis. Redis is a memory key value store. It's originally designed to store data just in memory, but it's now been adapted to allow you to store data on the disk as well. It's often used as a cache storage and is extremely effective as a cache. It's generally used for data that if the data is lost, it is not the end of the world scenario and the system can recover. If the data is being lost would be a major issue for your company, you should not use Redis to store that data. Redis is often considered only as a key value store for string values and a faster stand-in from mcacd. However, Redis can handle multiple data types such as lists of strings, hash data.